This is Climate Watch. I'm Zhao Ying. Welcome to the show. Emperor penguins are often seen as icons of resilience. They are the largest living members of the penguin family, and the only ones that breed during the Antarctic winter. During the dark polar winter, male emperor penguins huddle together on frozen sea ice. For months, they balance their eggs on their feet without eating anything, relying on body fat stored during the summer. For generations, these birds have survived one of the harshest environments on Earth. But now, climate change is happening faster than they can adapt. The International Union for Conservation of Nature has moved the emperor penguin's status from near threatened to endangered. Scientists warn that the early breakup and loss of sea ice could halve their population by the 2080s. But emperor penguins are not the only species feeling the impact of the changing Antarctic climate. The Antarctic fur seal has been moved from least concern to endangered on the Union's red list, as rising ocean temperatures push their main food source, krill, into deeper waters. Meanwhile, southern elephant seals are facing growing threats from avian flu outbreaks. So what is happening at the bottom of the world? Why are species that have survived for thousands of years now at risk? And as scientists and policymakers gather in Hiroshima for the 48th Antarctic Treaty Consultative Meeting this month, what collective action can we expect? Joining us now is Zhang Yimo, Priority Project Coordinator of WWF China's Sustainable Blue Economy Program. Yimo, it's great to have you back on our show.
Hi, everyone. Thank you for having me.
So, usually status changes are incremental, but why did the IUCN move the emperor penguin straight to endangered? And what exactly does endangered mean?
Well, endangered means a species is facing a very high risk of extinction in the wild. A quick refresh for all our audience. The best rate in the IUCN Red List is least concern, and such species, or to be precise, a taxon, is considered safe from extinction. When the situation of a species deteriorates a bit, it moves to the level near threatened. A species near threatened, like the emperor penguins before, is still not considered endangered. The three levels of being really problematic are vulnerable, endangered, and critically endangered. In an unfavorable but a common fashion, situations of species degrade gradually along the levels I just mentioned. This time, for the emperor penguin, the IUCN skipped the vulnerable category, moving from near threatened to endangered because of the sheer speed and scale of the threat. We aren't just looking at a gradual decline. It's a sudden drop in the past decades.
So can you walk us through what's happening to emperor penguin right now? Because they have survived extreme Antarctic conditions for thousands of years, but what's different this time?
Well, all creatures have their own capacity to survive in the nature. Camel endure dryness. Mangroves as bushes tolerate salt water. Rabbits and rats reproduce in large numbers to avoid being overpreyed. These are all shaped up by the climate, geographic, and organic conditions certain species have lived in over the last thousands, millions, and sometimes billions of years. Meanwhile, creatures can all adapt themselves to a range of climate fluctuations. A good example is the Darwin finches, referring to about 15 finches living in the Galapagos archipelago. These little birds played a key role in inspiring Darwin in the theory of evolution. Why are they famous in the theory of evolution? Let me explain. Due to the El Niño and La Niña processes, the precipitation and temperatures in the Galapagos vary dramatically among years. But these finches can adapt themselves in their bills so that they can always survive in their isolated islands by eating different kinds of fruits yielded after different precipitation conditions. These are visible evolution. However, evolution is very cruel. It means the ones that are unable to adapt die, while the surviving ones can pass on their genes to the next generation. I take this example to explain that within a certain range of condition fluctuation, species can adapt Emperor penguins, the species we are talking about today, have adapted the harsh climate and ecological conditions in Antarctica. They breed on ice instead of warm nests. Their special feather structure keeps themselves warm in a place where no other birds can. They swim rather than flying to feed. In one word, they perfectly match the least favorable living conditions for human beings. However, although they also have the capacity to face new challenges, the changes in Antarctica are far beyond the extent to which emperor penguins can rapidly adapt, like Darwin finches. What we are now seeing is the warming happening caused by humans just in decades, an extremely short period in the scale of evolution. Let's remember, adaptation requires generations, or to be specific, the sacrifice of several generations, where some capable individuals can pass their appropriate genes and traits over the next generations. That requires sufficient periods of time and the success of breeding of new generations.
We often hear that the ice is melting, but scientists point out that fast ice is the real issue here. So can you explain the difference between floating ice and fast ice and why the emperor penguins are so picky about it?
Yeah, there are differences. The floating ice is dynamic and drifts with the wind and currents in the ocean. Fast ice is fastened to the coastline, ocean floor, or grounded icebergs. It's stable, solid platform. Emperor penguins are heavy birds. They need that thick, stable fast ice to support massive colonies for 8 to 9 months. During this period, they court, incubate their eggs, and wait for their chicks to grow waterproof feathers. If that fast ice breaks up before the chicks fledge, the result can be deadly. The penguin chicks fall into the water and freeze or drown. What is even worse, scientists observed a mass scale of such phenomena. Sometimes whole breeding colonies fall into the sea. The tragedy is likely to continue. Population modeling, considering a wide range of future climate scenarios, shows that without abrupt and dramatic reduction in greenhouse gas emissions, emperor penguins' population will rapidly decline during the century.
Okay, well, as you said, Antarctica has gone through natural changes before, although not at this pace. But are there any evidence that emperor penguins are perhaps shifting breeding sites or moving to new areas?
Before answering this question, let me introduce the special role that Antarctica has played in studying the historic climate conditions. Scientists drill deep into glaciers and ice sheets, especially in Greenland and Antarctica, to extract cores and containing trapped air bubbles from thousands of years ago. These bubbles preserved exact atmospheric composition, including the carbon dioxide and methane levels. The ice layers also contain isotopes that reveal past temperatures. These studies from ice cores represents the most powerful record of the climate history on the Earth. Through such studies, human beings have understood the natural climate change in the past. In imprecise but easy to understand words, the temperature of Antarctica fluctuated in an interval of several degrees in the past millions of years. Therefore, the penguin have enough time to adapt and evolve. This time, in the Anthropocene era, the global temperature has already risen more than 1 degree in temperature in just half a century, maybe even shorter. So scientists have seen some marginal signs of behavioral adaptation. In some locations where fast ice has thawed, penguins moved their breeding sites up onto the permanent ice shelves. But this is just a stopgap, not a solution. Ice shelves are harder to access. They have different microclimates, and ultimately suitable habitats is shrinking across the entire continent. There are only limited places they can retreat to. So we have seen some of this behavioral change, but that's far from enough.
Okay, yeah, but if we know a penguin colony is at risk, like if the ice is about to break, should humans intervene? Like, can we help them move to safer ice?
Well, usually direct intervention like moving penguins manually is not feasible, nor is it on a sound conservation strategy. These colonies consist of thousands of birds in some of the most remote, hostile environments on Earth. Penguins choose one place not only because the fast ice, though it is now the bottleneck for their survival at this moment, but also for other reasons, possibly for the distance to other colonies or the access to food. So how do we know that one place is better than another? And meanwhile, even if we could move one colony, where do we put them when the entire region's ice is destabilizing? So another challenge is that both human and penguins carry some unknown pathogens that may harm each other. In fact, human beings should always keep a distance from wildlife. This risk is systematic and may cause even larger problems. Therefore, the only meaningful intervention is to address the root cause, dramatically cutting the global carbon emission to stabilize the ice dynamics.
Okay, and apart from the emperor penguin, the Antarctic fur seal has also been moved from least concern to endangered. What is driving such a steep decline in its population?
Yeah, that's true. The Antarctic fur seal has moved from the least concern to the endangered on the IUCN Red List, as its population has decreased by more than 50% from an estimated 2 million mature seals in 1999 to less than 1 million in 2025. The ongoing decline, again, is driven by climate change. A simple result chain looks like this. Climate change leads to a rise in the ocean temperatures and a shrinkage of sea ice. Since the young krill rely on sea ice algae to survive the winter, less sea ice means less algae, which means less krill. Some krill dive into greater ocean depths in search for cold water. This reduces the availability of food for seals. Krill shortages, for example, at the South Georgia, have reduced the survival of pups of the fur seal in the first years dramatically, leading to an aging breeding population. The climate change at the macro level leads to the changes at a microscopic level. Then a domino effect follows, leading to the collapse of the food web, which fur seals rely on, especially regarding the Antarctic krill. And meanwhile, the other threats, such as the predation by killer whales and leopard seals, and meanwhile the competition with the recovering baleen whale population targeting the same population of krill, are potentially also impacting the declining population of the Antarctic fur seal.
Yeah, and actually fur seals once rebounded from near extinction after intensive hunting, but this current climate-driven decline is arguably more permanent than the threat of hunting.
Yeah, in the old times, when people hunted for seals, hunters remove actually only individual animals. In that process, something critical was not touched, the food for fur seals and their habitats. These are the resources that fur seals need for their population growth. Once people stopped hunting, fur seals could still gradually thrive thanks to the existence of key resources, as long as there is a sufficient remnant population size. However, compared with the risks posed by the intensive hunting, the climate-driven decline is systematic. And nowadays, these critical resources are gradually diminishing. Suitable sea ice as habitats are shrinking and becoming less connected, and krill are becoming less available, both due to their distribution shift and human harvest. So unfortunately, almost all supporting elements are now becoming bottlenecks.
Okay, well, as you said, the krill are now moving to deeper, colder waters. But why can't fur seals just also dive a little deeper to get them?
Well, biologically and ecologically, it is not that easy. Let's imagine a village where people's survival depends on the mountain nearby. They go to the mountains every day to collect berries, hunt deer, chop firewood, and then go back home before it gets dark. They cannot spend the nights in the mountains due to the coldness and the evening, and in the evening, the dangerous wildlife like moose. These villagers have been living like this for thousands of years. And just to imagine, one day a factory is built near the village. The smoke from the chimneys make some berries hard to survive, and the villagers have to go further uphill to collect enough berries. Meanwhile, since there is less food, deer move to even higher places of the mountain, become harder to hunt. However, since the villagers can't spend their nights in mountains, the amount of food they bring home every day declines. As time goes by, then they find themselves unable to feed more babies, and some babies die at an early age, either because of the insufficient food supply or more frequent absence of the parental care due to the longer traveling time to the mountain. Several years after the factory comes, the village is doomed to shrink. Even some strong villagers may still survive. They live in an unhealthy and unstable condition. In the story, berries are krill, deer are fish, wolves are predators like killer whales, and home is a place where fur seal take them as a habitat. To explain this in a serious way, it's a matter of biological economies. For fur seals, particularly nursing mothers, operate on a very tight energy budget. Diving deeper or swimming much further offshore brings more calories. If they spend more calories or more energy hunting than they get from the kill they catch, they starve. And the pups waiting for them on the beaches starve. There's a hard physical limit on how hard they can work for their food. It's a budget issue, right? It's just like spending your money to invest. Therefore, although the krill are still in the ocean and the fur seals can still catch them, there's a loss in the energy investment. Catching them do not lead to energy profit, thus sustain or enlarge the population.
Well, just now you mentioned baleen whales, which are competing with fur seals for the resource in the Southern Ocean. Can you explain more on that?
The recovery of baleen whales, as well as many other species that have bent the curve of population decline, gives us confidence. Through appropriate intervention, it is possible to bend the curve of population decline. In China, for example, the recovered population of two symbolic and endemic species, the giant panda and Yangtze finless porpoise, which our organization also contributes to conservation efforts for, tells a similar story. I would share this optimism to our audience so that we still keep hope for the conservation. And let's come back to the question of whether the baleen whales compete for resources in the Southern Ocean. Well, the competition has long existed through the history. There has been a balanced struggle for resources among baleen whales, fur seals, and other animals. When the threats of baleen whales are removed, hunting and ship strikes, well, equally thanks to the sufficient remnant population size, they come back. However, it is much more complex for fur seals. The combination of threats are rooted in climate change and concentrated commercial fishing, sometimes usually unnoticed. It is the overall reduction of the pie to share. It's not that the whales are eating more than their historical share. It's that the total resource is now too small to comfortably support the returning of whales, the seals, and the penguins simultaneously.
And also, I've read that some fur seal populations carry unique genetic traits. So if we lose specific colonies, are we also losing the tools the species needs to evolve?
Exactly. Biodiversity is not just about the species, visibly the numbers of species and their abundance, like the numbers of individuals and populations, but also about the diversity of genetic library and individual species holds. Specifically, isolated colonies might carry genetic adaptations for slightly warmer water, different diseases, or different foraging strategies. If those specific colonies die out, the species loses those specific evolutionary tools, making the remaining population much more fragile to future shocks. We can understand the genetic diversity as a possibilities to adapt and evolve, because it provides with a population of a species with more options to change. A genetically diverse population can better withstand disease outbreaks, environment shifts, and climate change. Some individuals will likely carry traits expressed by genes that help them survive. Low diversity increase inbreeding, which amplify harmful recessive traits and reproduce fertility and survival rates. It also narrows the evolutionary toolkit, making species less able to respond to new threats. Therefore, maintaining genetic variation is essential for long-term resilience and reducing extinction risk.
Okay, and also the southern elephant seal was moved to vulnerable, specifically due to avian flu. So is this purely a natural outbreak, or is climate change increasing the risk and severity of disease?
It's a heartbreaking thing that these three large animals in Antarctica were moved towards the endangered level at the same time. The southern elephant seal has moved from least concern to vulnerable on the IUCN Red List following the decline caused by, we call it, highly pathogenic avian influenza. There has been a significant increase in the prevalence of avian flu around the world since 2020, and it has spread to animals, to mammals, which the H5N1 virus itself is natural. Climate change acts as a severe threat multiplier. I would say that such outbreak is caused by two reasons resulting from climate change. The first reason is that the southern elephant seals are now more prone to being exposed to pathogens. Changing global temperatures alter migration routes of white birds, which are the primary vectors bringing pathogens into new, biologically naive regions like Antarctica. In other words, the southern elephant seals used to be relatively isolated from these birds, but now they meet more often. Furthermore, animals already stressed by warming waters, shifting ice, and food scarcity have compromised immune systems, making these outbreaks far more lethal than they arrive. The second reason explains how the disease spreads. Due to the climate change, animals have to stay closer than before. Such colonies provide opportunities for disease to jump from one colony to another. According to studies, the disease has affected 4 or 5 major subpopulations, killing more than 90% of the newborn pups in some colonies and seriously impacting adult females, which spend more time on the beaches than males. So the climate change brings both the access and the spread of avian flu for the southern elephant seals.
Well, the IUCN has described Antarctica as a guardian of the planet. So if that guardian is now under threat, what does it mean for the stability of global systems and for our human societies far beyond the region?
Well, Antarctica is called the guardians for the planet for reasons. It acts as the engine room for the global climate. The ice reflects solar radiation, the cold water drives global ocean circulation, the currents that dictate weather patterns worldwide. If Antarctica destabilizes, we aren't just losing penguins or seals, the impact are far beyond the remote continent itself. The most direct and consequential impact is the sea level rise. Antarctica holds enough ice to raise global sea levels by tens of meters if it all melts. While complete collapse would take millennia, even partial destabilization matters enormously. Since most major cities are along the coast, the sea level rise will cause huge disasters to these human settlements. Well, secondly, when the climate of Antarctica shifts, global ocean circulation would be severely disrupted. Antarctica drives deep water formation and the southern ocean carbon sink. Warming could weaken the sink, allowing more greenhouse gas to accumulate in the atmosphere and accelerate the climate change. And thirdly, reduced ice cover lowers the reflection of solar radiation, causing oceans to absorb more heat. And weakened carbon absorption and the potential release of subglacial methane would further intensify global temperature rise. Therefore, the global climate pattern may change due to what happens in Antarctica. And this will also impact the food and economy security, which we all rely on.
Okay, we know that the Antarctic Treaty Consultative Meeting is being held in Japan this month. What concrete actions are on the table?
Well, we need to move the past Arctic and security binding spatial protections. So the Commission for the Conservation of Antarctic Marine Life Resource, or which is short for CAMLA, must mainly agree to designate long-proposed marine protected areas in the Weddell Sea and the Antarctic Peninsula. These areas shall act as vital climate refuges. And second, we need much stricter dynamic catch limits on the commercial creel fishing industry so that the animal we are talking about today can get their share before vessels take them. And finally, we must integrate blue financial principles, holding supply chains and investors accountable so that the capital funding southern ocean fishery is tied directly to stringent sustainability and conservation metrics. So we have the governance frameworks now, and we just need to enforce them. We see momentum, so let's hope the protection will happen.
Thank you, Zhang Yimo, Priority Project Coordinator of WWF China's Sustainable Blue Economy Program. Thank you so much for joining us today. And that wraps up this edition of Climate Watch. You can find more episodes on your favorite podcast platforms. Just search for Climate Watch and hit subscribe. Don't forget to leave us a quick review or share it with a friend. You can also email us at radio@cttn.com with your questions or feedback. And stay updated on the latest climate stories with our Substack newsletter, Climate Choices. I'm Zhao Ying. Thank you so much for listening. See you next time.